Okay, chapter 11 is what we're starting today, and it's all about circumference, area and volume. Okay, so the first one we're just going to talk about circumference and arc length. Okay, so a circumference is the distance around a circle. Okay, distance around a circle. So the circumference of a circle is denoted by a capital C. So in it is capital C, or circumference is equal to pi times d, or circumference is equal to 2 pi r, where d is the diameter of the circle and r is the radius of the circle. So it makes sense that pi times d or 2 pi r would be equivalent, because 2 times r is the same thing as the diameter, okay? So that's all that I have there. So if we go down to example 1, it says find the indicated measure. So part A says circumference with a circle of a radius of 9 centimeters. So if it gives us the radius, we want to use that C equals 2 pi r. So 2 pi times the radius is 9. Okay, that is 18 pi, which is approximately equal to 56.55. Okay, now make sure we know where the pi key is in a calculator. Okay, it's right here. Okay, we like to use that instead of just 3.14 because it's more precise this way. Okay, so the next one is that it wants to know the radius of a circle with a circumference of 26 meters. Okay, well again, it's referencing a radius, so I know I need to use C equals 2 pi r. Okay, but this time I know that the circumference is 26, so I'm going to do 26 equals 2 pi r, and I'm solving for the radius this time. So I'm going to divide by 2 pi. Okay, 2 pi is just a number. Okay, and that's going to leave me with the radius all by itself. Okay, so in your calculator, if you do 26 divided by 2 pi, make sure if you aren't using a calculator like this, okay, and actually even if you are using a calculator like this, I'll show you the 2 different ways that you can do it. 26 divided by, if you hit 2, oops, that's not what I wanted. Yep, if you just click 2 pi, and I hit enter, you're going to get 40.8, okay, which I did write a 4, so you guys are probably thinking that's the correct answer. But what this just did, excuse me, my voice is cracked. What this calculator just did, it did 26 divided by 2, and then since there wasn't parentheses, it thinks that you want to multiply this 26 divided by 2 by pi. So instead, if you want to put it all in at the same time, you have to use parentheses and do 2 times pi. Gosh, I just did that again. 2 times pi like this in parentheses. Now you can divide by. Okay. I think you can also, let's confirm my theory here. You divide by 2 and then divide by pi. I just hit the second key again. You don't have to hit the second key. You also get the same answer out. Okay. So you should get that 4.14 is approximately equal to the radius. Okay. So the next part, the next vocabulary word is arc length. It is a portion of the circumference of a circle. Kind of ran into my vocab space there. Okay, so an arc length is a portion of the circumference of a circle. So we have an arc length formula then. So arc length, in a circle, the ratio of the lengths of the given arc to the circumference is equal to the ratio of the measure of the arc to 360. Okay, so we have this ratio, like it's saying. Okay, so the arc length of segment AB is over 2 pi r. So basically that's telling you that the piece of the circle over the whole circle, because this is our circumference, is equal to the measure of the arc AB, so that's like the degrees, right, over 360, because that's the piece of the whole. Okay, so again, it's the piece of me measuring it, okay, with like, if I was going to measure it with like a tape measure or something, I know that would be difficult because it's a circle, but if we were to stretch it out, this is what I would get. Okay, whereas this is about degrees over 360. Okay, so if you want that all in terms of, let's just look at it really quick and set it equal to something. Okay, you can also think of it as arc length is equal to the measure of arc AB over 360 times 2 pi r, okay? Just because if I multiply both sides by 2 pi r, it's going to move over here. So then you just get arc length of AB equals the arc over 360 times the circumference, okay? So you can think about it either way, whatever makes more sense to you, if you want to set up the ratio or if you just want to plug it into this formula and go, okay? So now let's look at that in an actual problem. Okay, I like to use it in formula format. Okay, so where it's just like x equals, and that's what I'm solving for. Okay, so the arc length I'm going to call x is equal to the measure of the arc is 60 over 360 times 2 pi, and then the radius is 8. Okay, so if you plug that all into a calculator, okay, you can kind of do it. I like to do it in like segments kind of. So 60 divided by 360. Okay, and then you can go ahead and just type the, or hit the multiplication key, and it's going to come up with this answer. So it's going to take the answer of what I just did, and now I'm going to multiply it by 2 pi 8, and you get 8.38. And it's measured in centimeters here. Okay, so I know that that's my answer. Okay, now in this one, it wants to know the circumference of circle Z, okay? So it's giving me different pieces. Now I gotta find the circumference. So if you remember right, it was arc length, over your circumference is equal to the measure of the arc, xy, over 360. Okay, so it wants us to solve for C right here. So it's telling me the arc length is 4.19. I don't know what C is, equals the measure of the arc is 40 over 360. So just cross multiply and divide. 360 times 4.19 divided by 40, and you get 37.17. Or sorry, not 1771, 37.71. Okay, and it is measured in inches. Okay, and lastly, part C, it is looking for the measure of arc RS. Okay, so it's telling me that the arc length is 44. Okay, and the radius is 15.28. So if that's what the case, then I know that this is 2 pi times 15.28. Okay, equals x, what I'm looking for, over 360. Okay, so you can simplify this to be 44, or sorry, I'm going to leave 44 alone. I'm going to simplify this on the bottom just to make my steps a little bit easier. And you get basically 96.0 equals x over 360. So I'm going to do 360 times 44 divided by 96. And you get roughly 165. So the measure of arc RS is equal to 165 degrees. Okay. Example 3. It says the dimensions of a car tire are shown. To the nearest foot, how far does the tire travel when it makes 15 revolutions? Okay, so step 1 is find the diameter. Okay, so the diameter would be 15 plus 2 times 5.5, right? To get from one side of that circle all the way across to the outside of the tire, that would be 26 inches. Okay, so then step 2 is find circumference. So capital C equals 26 pi. Okay, and you can just leave it like that for now. We don't need to simplify it. So then step 3 is find distance traveled. Okay, so 1 revolution, well, how far would my distance be? Well, it would be, my distance would be equal to my circumference. Okay, so then if I want to find what it is for 15, my distance would be 15 times my circumference. So 15 times 26 pi, which is approximately equal to 1225.2 inches. Okay, but it wants to know to the nearest foot. Okay, so if I have that in inches, okay, that is the same thing as doing 1 foot over 12 inches. Okay, so then the inches cancel out, and I'm left with feet. So I'm going to take my answer, which is 1225.2, and divide it by 12, and you get 102.1 feet. Okay, example 4. So it says the curves at the ends of the track shown are 180-degree arcs of circles. The radius of the arc for a runner on the red path shown is 36, which I know you can't see the red path, but we'll talk about that in just a second. Is 36.8 meters. About how far does this runner travel to go once around the track? Okay, so it looks like the red path is to this middle one. So this is our radius to the path. So this is our 36.8. Okay, so our distance, total distance, is equal to, wouldn't you say that there's 2 curves, right? So 2 times the length. There's 2 curves and 2 straight sections. So 2 times the length of each straight section. Plus 2 times the length of each semicircle. Okay, so if I have the length of the straight section, okay, that is just 84.39 because it's listed there for us. So 2 times 84.39 plus 2 times, okay, now I have the length of each semicircle. So I'm going to want the circumference, but I'm actually going to want half of the circumference. And that would be times 2 pi, and then the radius is this 36.8. Okay, the 1/2 and the 2 cancel out, so it's really the same thing as doing 2 pi times 36.8. Okay, and if you add all of that together, you should get approximately 400.0 meters, which is what you want whenever you travel around the track one time, right? Okay, so then let's turn the page, one last page here. Okay, so measuring angles in radians. So it says, recall that in a circle, the ratio of the length of a given arc to the circumference is equal to the ratio of the measure of the arc to 360 degrees. To see why, consider the diagram. A circle radius 1 has a circumference of 2 pi. So the arc length of CD is the measure of arc CD over 360 degrees times 2 pi. Recall that all circles are similar and corresponding lengths of similar figures are proportional. Because the measure of arc AB is equal to the measure of arc CD, AB and CD are corresponding arcs. So you can write the following proportions. The arc length of AB over the arc length of CD is equal to R over 1. So the arc length of AB is equal to the radius times the arc length of CD, and the arc length of AB is equal to the radius times, okay, we know the arc length of CD is the same thing as the measure of arc CD over 360 times 2 pi. This form of the equation shows that the arc length is associated with a central angle. and it is proportional to the radius of the circle. The constant of proportionality, this measure of arc CD over 360 times 2 pi, is defined to be the radian measure of the central angle associated with the arc. In a circle of radius 1, the radian measure of a given central angle can be thought of as the length of the arc associated with the angle. The radian measure of a complete circle, 360 degrees, is exactly 2 pi radians. Because of the circumference of a circle, the radius 1 is exactly 2 pi. You can use this fact to convert from degree measure to radian measure and vice versa. Okay, so if you are going from degrees to radians, okay, what you're going to use to convert is 2 pi radians. I'm going to abbreviate radians with rad over 360. Okay, or that simplifies down to be pi radians over 180 degrees. Okay, same thing over here. Radians to degrees now, we just flip what's on top basically, 360 degrees over 2 pi radians. Or you can think of that as 180 degrees over pi radians. Okay, so what you're going to do, we are on part A. It's going to say convert 45 degrees to radians, okay? And this is going to come in, I should maybe preface this example, is that we aren't going to use this a whole lot in geometry, but as you move forward, especially once you get to pre-calculus, radians are going to be pretty important, okay? Probably pre-calc and calc. Okay, so convert 45 degrees to radians. So you're going to take 45 degrees. Okay, and think we want it to cancel out. So if I'm going to get it to cancel out, I want my degrees to be on the bottom. So I'm going to do 180. So you can think of this as over 1 if you want. You're going to multiply that by pi radians over 180 degrees. So you can kind of think of these degrees, since one's on top and one's on bottom, they're going to cancel out. So then you would get 45 pi over 180. Okay, and you can divide 45 and 180 both by 45. So then you would just get 180 divided by 45 is 4. So you're going to get pi over 4 radians. Okay, then convert 3 pi over 2 radians to degrees. So 3 pi over 2 times, okay, again, the radians are what you want to cancel out, so I want the radians on the bottom. So pi radians below 180 degrees. Okay, so the radians cancel. I'm left with degrees. Okay, and if you multiply that out, you should get 270 degrees. Okay, again, like I said, not going to come into like big play here in geometry, but it will be important moving forward. So let me know if you have any questions.